Alright guys, we're going to start the second half of Unit 1. In this one, we're going to start off by looking at what are called quadratic equations and quadratic functions. You should have seen these in Algebra 1 or Algebra 2 if you took that. Basically, a quadratic function is a function that looks something like this in standard form. Y equals ax squared plus bx plus c. In this, a, b, and c are going to be just some values. The x squared, the x, and the y are always going to be just like they are. We know it's a quadratic because of the x raised to the second power, okay? Because we see the second power there, all right? If we look at our first example, well, how are we going to identify these quadratics? Okay. Well, in this first one, you'll see what type of function would best model the data set below. Well, the first thing we're going to do is we're going to check, is it linear? Okay. Well, we know how to check linear. We learned that in the last section. We would take the difference between each of these and see if they're the same. If they're the same, then we know it's linear. So we do 1 minus 0, 6 minus 1 is 5, 15 minus 6 is 9, and 28 minus 15 is 13. Now as you see, these are not the same, so we know that it is not linear. Okay? So the next thing we're going to check is it exponential? All right? Well, I'm going to write down here to check to see if it's exponential. We're going to divide. All right. Well, 1 divided by 0 is, well, that's actually undefined. We can't even divide that. If I go to the next one and I do 6 divided by 1, well, 6 over 1 is 6. Already those aren't the same, so we can say that it's not exponential. Okay. The last thing we're going to check is quadratic. Okay. So to see if it's quadratic, we're going to take these differences we got from the linear, and we're going to actually find what we call the second difference here. If the second difference is the same, then we have a quadratic. Well, 5 minus 1 is 4, 9 minus 5 is 4, and 13 minus 9 is also 4. So, it has the same second difference. So that means it is a quadratic. Okay. Now if I want to take this a step further and I want to actually find this quadratic equation, I would simply do that by finding what A, B, and C are. Okay? So I need to find out what A, B, and C are. Well, I first do that by setting 2A equal to the second difference. In this case, it's 4. Well, if 2a equals 4, divide both sides by 2, and you get a is equal to 2. All right, so there's my a value. So I know my equation is going to start with y equals 2x squared. All right, so there's my first piece. The next part is that a plus b is equal to, now for this, I go to this value between 0 and 1, okay? I find x equals 0 and x equals 1, and I find the difference between the y values. In this case, it's 1. So a plus b equals 1. Now if I plug in what I have for a, 2 plus b equals 1. Now I need to solve this for b. I'm going to subtract 2 from both sides. All right. That's going to simplify out, and I get b equals negative 1. So I have 2x squared. My b is a negative 1, so I have negative 1x. Now my c value is going to be where x equals 0. Well, where x equals 0, my y value is 0 for this one. So my c value is just 0. So I would simply just have a plus 0 at the end, or I could just leave it blank. Either one's fine. So there would be my final equation. All right. Let's try one more of those. Okay, here's example 2. Now this one I'm going to go ahead and tell you that this one's quadratic. So we're going to start off by finding all of these first differences, which should not be the same because, as I said, it's a quadratic. So 1 minus 0 is 1. 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. And you can probably already kind of see that there's a pattern there. Now, if I find the second difference here, well, from 1 to 2, I went up by 1. From 2 to 3, I went up by 1. From 3 to 4, I went up by 1. Okay? So now we're going to set up our equations. 2a is equal to this value here. Okay, so 2a equals 1. Divide both sides by 2, and I simply get a is equal to 1/2. All right? Now I know a plus b is equal to this value here between 0 and 1. Okay? Remember, I look at 0 and 1 on my x's, and then I look at the difference between the y's there, which is 1. All right? I plug my a value in. 1/2 plus b equals 1. I'm going to subtract 1/2 from both sides. That's going to simplify out, and I get b equals, well, 1 minus 1/2 is just 1/2, so b is also 1/2. Now my c value is, again, I look at where x equals 0, and I look at my y value. My y value is 0, so my c value is 0. So now my equation I would write would be y equals 1/2, which is my a value, x squared, plus 1/2, which is my b value, x, plus 0, which is my c value. All right? So now this one's kind of written out. I don't have the table, but I have some of the information that I would get from the table. Okay? If the second difference is 4, the y-intercept is 0, 1, and a plus b is 5. Well, the second finite difference is equal to 2 times a. So if 2a is 4, divide both sides by 2, and I get a is going to equal 2. Now it told me that a plus b is equal to 5. Okay? If a plus b is 5, well, 2 plus b is equal to 5. If I subtract 2 from both sides, simplify that out, and I get b equals 3. Now my c value is simply the y value when x equals 0. When x equals 0, my y value is 1. So now if I plug this in, I simply have y equals a, which is 2, x squared, plus b, which is 3x, plus my c value of 1.